across the board that climate change is happening and that it's accelerating and that humans are the cause.
To quantify the impacts of climate change on the winter sport recreation industry, climate change could cost over $1 billion a year.
The more we can reduce emissions today, the more of winter we can preserve for our children.
These things are being made worse by climate change. The science is there. So we are no longer talking about the future. We are talking about the here and now.
Hi, everybody. Welcome. Thanks for tuning in tonight to head back to school with Protect Our Winters and get a little climate science primer. I'm your host, Chris Davenport, professional skier, longtime POW board member, and tonight we are going to learn more about how climate change is impacting the places we play. Specifically tonight, right here in the Rocky Mountains. So I'm really thrilled that all of you could join us tonight, and there's going to be a lot of great information. We're going to do some Q&A at the end, so please make sure you throw any questions you have in the chat on the right. We love all of the conversation. Welcome from Los Angeles and Denver and Boulder and Breckenridge and on and on. This is your opportunity to ask our local experts about how climate change impacts our own backyard. I know if you're like me, you get asked all the time, well, like, how do you actually see it? Like, what's happening? Well, tonight we're going to find out. So I want to welcome our esteemed guests tonight. We have Dr. Mackenzie Skiles, who's from the University of Utah, and Dr. Keith Musselman from CU. Go Buffs! All right, you guys. So this is so important to me because I'm out there talking to groups. I'm out there, skiing, talking to people all the time, and I'm asked about climate science. And I want to know first off how you guys got involved with the outdoors. Like, where does your passion come from? It must have been something in your young life that drove you, towards the field of study that you chose in school, and especially here in the Western Mountains, in the Rockies. So, Mackenzie, let's start with you. What's your favorite activity and your favorite local outdoorsy spot?
Yeah, great. I'm so excited to be here, and thanks to everyone for signing on. And how I got into what I'm doing is I grew up in Alaska, and I spent a lot of time outside, mostly skiing and snowboarding. If anyone's from Anchorage, I was a ground on the hill, on the slopes at Hilltop Ski Area. And growing up in Alaska, you just can't deny that climate is changing and that it's impacting the places where we live. Just one of the things that's really impacted me a lot is watching homes up in Alaska that were built on permafrost start to sink into the landscape because there's no more solid foundation. So that, in combination with watching local ski slopes change and snow cover and snow lines change, really motivated me to get more into the science of climate change and what's going on. And I found a way to combine my love of snow with my interest in climate change. And that's kind of led me to where I'm at right now.
I love that story. I love the snow, and I'm not a scientist, but that's what's got me involved with POW, which is, it's such a cool connection. Keith, what about you?
Yeah, thanks, Chris. Thanks everyone for tuning in. I grew up about as far away from Mackenzie as I could in the U.S. I grew up in New Hampshire, and in New Hampshire, I found the weather to be both frustrating and fascinating. I quickly learned as a skier and a snowboarder that you could go up in elevation to get away from the typical rain that you're used to in the East Coast. So and find this zone of powder, and I became a hound for it, and I quickly found an interest in weather and climate, and ultimately in water resources, which launched me first to the west, where I was rolling burritos in Big Sky, Montana, and I met my wife, who's a ski patroller there, and then into graduate school, where I just continued my passion of understanding snow.
Nice, Keith. I didn't realize your wife is a ski patroller. Mine is too. So cheers to the ski patrollers out there. That is awesome. Mackenzie, so you're in Utah. You're assistant professor of geography in the geography department at the University of Utah. I think your focus is on snow hydrology. So how did you move from Alaska to Utah, take that role, and tell us about your job, your day-to-day? Like, what are you studying?
Yeah, so well, to be perfectly honest, I picked the University of Utah for my undergrad because I wanted to ski.
Yes, like so many
And
people.
it was really close to Alta and Snowbird, and I did not think at all about the academics. But I was able, while I was there, to meet a professor who did study snow, and that's how I realized I could connect those two. And from that point on, science and snow kind of just went hand in hand. And as a snow hydrologist, it's not just skiing for me, it's a natural resource. We get most of our water in the West from snowmelt. So it's really important for me to understand how we best utilize that resource and how that resource is changing over time, which has both climate and hydrologic implications. So day to day, what I'm doing is I combine field work. So I have field instrumentation sites all over the West. I combine field work with numerical modeling and remote sensing, so looking at snow from satellites, to understand how that resource is changing over time, and how we can better monitor those changes, and then ultimately, how much water are we getting from that snowpack.
That's awesome. I know that you get to work, and both of you get to work in really cool places, because I sent you guys some photos, and Mackenzie, you were like, oh yeah, I've spent a lot of time there. So we're gonna bring up some of those photos later on in our conversation, but amazing places to ski and snowboard are also amazing places to do some really interesting science. Now, Keith, you are at CU Boulder. That's my alma mater, and great place to work in snow or snow hydrology. So tell us exactly what you're doing there in Boulder.
Yeah, thanks. So I'm at an institute called the Institute for Arctic and Alpine Research, and we focus on alpine regions, Arctic regions, cold regions, really. So places where snow plays a substantial role in the water balance. And I do very similar work to Mackenzie, a balance of field work and numerical modeling. Before I came to CU, I was working at the National Center for Atmospheric Research, where I kind of cut my teeth a little bit in the climate science field of things and trying to understand how snow will change in the future. We can talk a little bit more about that towards the end of our talk. And more recently, I've been working up in the Arctic, up in Alaska and Western Canada, and some really beautiful places, but more of a focus on how Native Alaskans and indigenous peoples are being impacted by climate change.
Just to follow up quickly, Keith, would you say that those people are oftentimes adversely affected compared to people maybe in the lower 48? The Arctic regions, I imagine in my mind, have greater impacts from climate change.
Totally. Yeah, they've got two things working against them. One is that they don't have the voice that many of us do. And the second is that they live in a place that is rapidly changing, probably faster than anywhere else on Earth.
Well, I want to thank all of you guys for joining us tonight. We're getting some great comments in the chat, people from all over the country here. Let's talk about sort of the basics of climate science 101, if you will. Just as a human, as a consumer, as a non-scientist, constantly have to remind myself about sort of the bullet points, the basics. So like if I'm on a chairlift and somebody asks me about that POW sticker and I start describing climate science to the guy next to me, I need to be pretty succinct. So Mackenzie, what tips and tricks do you have when it comes to just an easy explanation that everyone on this webinar and everybody in our community could use to describe what's going on with climate science?
Yeah, that's a great question. So I think it's important to keep it short and digestible, and then also to connect points that most people can agree on. So we know that since the Industrial Revolution, since we started using fossil fuels, that we've been emitting more greenhouse gases, specifically CO2, into the atmosphere. So that's not disputed. And then we also know that once CO2 gets in the atmosphere, it makes the atmosphere warmer. And that's also not disputed. That's been a part of our climate and keeping the earth warm for as long as there's been life.
Like the greenhouse effect is pretty well understood, right? Like if you walk in a greenhouse, it's warm. Okay.
Yeah. So we know, everyone agrees on that. And then we also know that temperature is increasing. We can compare proxy records like ice cores to the modern temperature record, and we know that it's increasing at a faster rate than it's ever increased before. And we know that that increase is in lockstep with the increase in CO2. So we can connect those two records to each other. And we can also say that it's happening faster than it's ever happened in our planet's history. So when people say, yeah, climate has always changed, no one disagrees with that. Climate has always been changing, but it's never changed at the rate it's changing today.
That's fascinating. Keith, maybe you can expand on that. First off, I know that our community, the outdoor state, 50 million people that love the outdoors generally trust scientists. I mean, we go to doctors and we go in school to biology and chemistry classes. Like, there's a lot of trust right there. And I know that from my own studies, it wasn't that long ago that we had an ice age here in the Rocky Mountains, maybe 15 or 10,000 years ago. There was glaciers from Canada all the way down here into Colorado. So as you said, Mackenzie, things have always been changing. Keith, can you expand on that? How did the acceleration happen? Was it just humans figuring out how to dig up dinosaurs and burn fossil fuels, or is there anything else?
Yeah, and I think Mackenzie summed it up nicely. And I think an important point to make is that there's no credible alternative explanation to what's happening in terms of the temperature and in terms of the CO2, that nobody yet has put forth anything that's even close to explaining what scientists understand now is the increase in temperature due to increases in emissions.
Okay, I have one follow-up question, because this person I know, I was going to say friend of mine, but this person I know threw out a hypothesis or an idea at a conversation I had this summer that had something to do with sunspots and the cycles of the sun affecting climate. Do you want to, Keith, quickly talk about that? I don't want to get too wonky here, but Is that a real thing?
It is a real thing in terms of the long-term variability, in terms of causing ice ages. There's a lot of thought that that solar changes, slight changes in the energy of the sun can cause an ice age. And that is not what's happening here. We have a very good understanding of what our sun is doing. We're watching it very closely, and we're able to model it now. And there's no correlation. It's, again, not a competing alternative explanation.
I just had,
Go ahead. Add to that maybe is that those changes happen over incredibly long time scale. We would never notice them in our lifetime. So the changes that we look around and see that's happening in our lifetimes, that cannot be changes due to variations in the sun's orbit or the Earth's orbit relative to the sun.
That's great. Yeah, thanks for clarifying that. I definitely, it definitely makes sense that the relationship between sun and Earth is at a much longer time scale than us humans, day by day, year by year kind of thought process. One more question for you too before we go on to the impacts of climate change on our own backyards. Oftentimes, if I don't have the answer to something, I will send people that are wondering to a website called skepticalscience.com. Is that a website you're familiar with or would recommend or know anything about? Either of you?
I don't know much about it.
I'm not directly familiar with it, so I can't vouch for it. But I could recommend an additional resource as well. NASA, they have satellites looking at our Earth all the time and are running models. And NASA has a great climate science website that really breaks it down into digestible pieces of information and backs that up with data. So NASA,
go NASA.
Science.
I trust NASA. If they can send people into space, I'm down. Keith?
I've seen a nice wrap up of Climate Change 101, and it's by a Dr. Kimberly Nicholas, who's a climate scientist from Sweden at Lund University. And she breaks it down into 5 points. She says, it's warming, it's us, we're sure, it's bad. And the fifth one is the most important, I think, is we can fix it.
I love it. Wow, I'm taking notes. I'm gonna look up her stuff. Thank you, Keith, for that. Let's talk about the Rocky Mountains. I mean, this is where we live. This is where we play. This is where we raise our families. There are impacts here. I have seen them in my own backyard on Colorado 14ers near where I live. Let's talk about how the climate change is impacting either short-term or long-term, our backyards. So there's localized impacts and there's regional impacts. Keith, why don't you talk about what you're seeing in your work, in your field, and in your study in this area?
Yeah, right. So thanks. I think one of the biggest impacts we're seeing is slight changes in winter snow, and we're seeing increased melt in the winter, and that's just over our lifetime. So if anyone out there has said, "Hey, man, it seems like the snow's wetter in the winter than it was when I was a kid," the data back that up. That's what our data are suggesting, is that we're getting more winter melt events, and that's just correlated with
It's just temperature. Okay.
It's just temperature. And some of the other things that we're seeing, so we're able to model what's going to happen in the future. So that's looking back over our data record, but we can model what we project if emissions continue at the rate that they're going. What's going to happen by the year 2085?
Not sure. I want to know. Are you gonna reveal it, or because I'm scared?
Yeah, let's pull up a slide. So that if you could pull up one slide for me, the one before that, if you could. Yep. So this is a map, and so we're just looking at colors. The colors represent the change in snowpack. So just think about how deep is our winter snowpack. And here's Denver and Frisco's called out there. You can see Utah on the left, Wyoming to the north. The colors in general over the Colorado high country are yellows. There are some spots of blue where we have little change in future end of century snowpack, which means that at the end of the century, might see a 10, maybe 15% change, a reduction in snowpack over the Colorado high country. The same thing is not true for the San Juans. If you know about the San Juans, you ski at Wolf Creek, those places. The same is not true for the Wasatch. These are lower elevations. They don't have the high elevations of really cold temperatures that make us resilient to warming. So I would say overall, Colorado high country is one of the few places in the West that is resilient to warming to an extent. It's going to take longer for that to start affecting our snowpack. If you go to the previous slide that we just saw, this is the projection for the whole Western North America. So if you ski Revelstoke at Whistler, Baker, Bachelor, if you ski the Tahoe region, you know that these are also places where you might pack Gore-Tex if you're going for a trip, right? They're places that currently in the current climate are wet. You could get rain anytime, even to the summits. In the future climate, we're getting very large changes, 50% reductions of half the snowpack that we see today, even more in some cases. And so I think going back to Colorado, we're kind of best case scenario. Winter snow sports are going to continue this century, but we're going to start seeing these impacts, wetter winter snow, not as good quality snow. And so this has trickle down impacts on things like wildfire that we're seeing right now, rampant in North America. And we can talk more about that, but maybe I'll step back and hand it back to you, Chris, for any questions.
Yeah, that's frightening. And 60 years out, 65 years out. A lot of the reason that I think we're all involved in the climate world and climate work and protect our winters is we want to leave the planet a better place for the next generation, for our kids and our grandkids. And looking at those slides, we have some work to do. But like you said, from the scientist from Sweden, number 5, we can do something about it. So Mackenzie, in the Wasatch Mountains, which on the slide that Keith just presented, are facing some challenges in the next 50 years. You've got some study plots. You're up there in the field. What are you seeing locally right now? And then we'll get into the future in the Wasatch.
Yeah, so I think one thing that's really important to remember with a warming climate is we often say climate change, and climate change equals climate variability. Oh, yeah. So it's just less consistent over time. So, climate is what you expect and weather is what you get, but more and more so, we're not getting what we expect. So we're in the accumulation season during winter, we're getting more rain rather than snow. During the middle of winter, we're getting more midwinter melt events. So that's what Keith was talking about. It gets warmer and then it melts earlier than we would expect it to. And then it's melting earlier in the spring. So when we get less snow to start and it's melting earlier in the spring, that combines to make a shorter winter season. And we see evidence of that both sides, in accumulation and melt in the Wasatch.
Thank you for that. And I want to remind everybody that's watching that we would love some questions from you. So if you have questions about your own backyard, where you live, Climate Science 101, put them up in the chat and we will try to answer them in a little bit. Keith, you mentioned resilience here in Colorado, and I think that's directly tied to elevation. It seems like as things warm, it makes sense that lower elevations are going to feel those impacts. But a couple words that have been sort of front of mind this summer are drought and fire. And I'm curious how the changing landscape affects winter recreation, for instance. I know that a lot of development in the desert Southwest over the decades has led to more dust in the atmosphere, and dust can fall on snow. But I think probably the same is and not that we get forest fires in the winter, but the same is true. Like when the landscape changes, it has all of these different effects. So maybe, Keith, you could just touch on, and then we're going to show some slides of some dust events, but just touch on how human impact on the landscape is affecting what we're talking about with climate.
Yeah, that may be a better question to pose to Mackenzie.
Mackenzie, feel free to swing at that home run.
Yeah, I mean, so one of the things that I study is the impacts of dust on snow, and with climate, it's we like to draw this simple line between warming temperatures and changes, but a lot of times it's not that simple. It's more complex, and it can involve things like the interaction between land use change. Where are humans changing the landscape and warming temperatures? And in combination, this leads to this kind of perfect storm of drought conditions out in the dry, arid landscapes of the southwestern US and other places in the world. And upwind of those spots is our mountain snowpacks. Right. So what happens is that this dust lands on snow, which is one of the brightest natural surfaces on Earth, and darkens it. And when it gets dark, it absorbs more sunlight and it melts much faster. And plus, no one likes to ski on dusty snow. It's terrible.
No,
That's a terrible photo.
Dust. I mean, it's just it's no fun. So not only is it no fun to ski, but it's also basically destroying our snowpack. It makes it melt weeks to months faster than it normally would. And this is one of those impacts due to climate change and land use change that's a little more nuanced, but it's definitely impacting our mountain snow.
And I know you've studied this a lot over the years. Is there an increase in dust events on Western region snowpacks compared to 40s, 50s, 60s, or however far back the science goes?
Yeah, that's a great question, because people always say dust, that's a natural aerosol. It's kind of always been around, hasn't it? And what we've seen is that there's been two major increases in dust. The first one came when the West was first settled. So the first big settlement across the West and grazing of sheep and cattle really broke up those surface soils. And then over the last 50 years, we've been seeing another increase in dust. And I think that also we've been able to relate that back to land use change and drought. And that's kind of the two factors that lead to more dust. So it's not a minor increase, it's a noticeable increase that we have been able to measure across all of our measurement stations in the Western US.
Yeah, and for anyone who's been in the Moab area, you might have seen signs that say "Don't bust the crust."
Yeah.
And so that's a living microbial community on top of the soil, and when it takes hundreds of years to form.
Cryptobiotic or something.
Something like
that. Cryptobiotic soil. Yeah, exactly.
And so that's the crust that is preventing this soil from going airborne.
Well, I can tell you personally, and you saw the photo, that was me and my friend skiing in the San Juans, that skiing on dust is awful. It's like skiing on sandpaper, and it makes you, again, people ask us, how do you see climate change? Well, I've seen a lot more of this kind of skiing going on, especially in the spring. And you guys mentioned it, the effects. It's not necessarily about recreation, although it does ruin skiing and snowboarding or make it worse. But the downstream effects with agriculture and water usages in places in the Colorado River Basin, for instance, that's serious. So Keith, maybe you could really just quickly touch on how it affects communities, cities, when we've got these big dust events happening. And then we're gonna quickly move on because we're getting a little bit geeky on dust on snow here.
Yeah, no, I might even pivot to water resources
good.
and thinking about, so the snowpack acts as a natural reservoir. So in my slide, I didn't call it out, but there was a little water tower. We think about mountain snow as a water tower because it stores water. If you lived in any small town that has this big water tower, that provides the water pressure that you need to turn on your faucet. And so the mountains do a similar thing. And it also holds water. It's a natural reservoir. Instead of having to dam a river and back it up, we have this natural snowpack that takes the precipitation when it falls, which is mostly in the winter in the West, and then releases it when you need it the most, which is in the spring and the summer when demand from agriculture, from cities, from our lawns, whatever, are highest.
Yeah, thanks so much for that. I had one sort of localized story. I live in Snowmass, Colorado, and we have a 14,000 foot peak right behind my house. It's the closest. I live on like Snowmass Creek Road. It's very close. And it was named in the late 1800s, I think, by the miners that were first there because it had this beautiful gleaming white permanent snowfield that stuck around throughout the summer. And over the course of 100 and something years, especially, well, it was there permanently. And then in the 2000s, probably by 2008-9, it was melting more and more and more every summer. And by 2012, it was gone. And now it doesn't exist anymore. And that's kind of one of the stories that I like to point to just kind of in my own backyard, that this thing that had been a remnant probably from the last ice age is now gone right in front of our face. I want to make sure that we get some questions up here from our team, from our followers, but also it's really important that we try to find and pull our biggest lever that we can in the climate world, or just in the world in general, which is elected officials and public policy. So I just want to encourage everybody before we get into some Q&A to get out and vote this fall. I know you've been hearing it from every corner. You might be over it, but it is so important. And Protect Our Winters has a great get out and vote tool. And we're going to put a slide up for that. Make a damn plan, because we all need to do it. So makeadamplan.org. Make sure you guys click on that. And just make a plan. I've got one in Colorado. We've got mail-in ballots. It's super easy, and hopefully it's easy in your state. And if it's not, maybe you could help us make it easy. I'm gonna check and see if we've got some good questions here on the way. I want to thank you guys for all of this great information. I mean, it's a lot to digest, and you can dig so deep down this rabbit hole of climate science. And I want to thank you for making it as easy as possible. All right, so we're going to pull up some questions right now. This is from Charlie. How can we best talk about yearly abnormalities? For instance, we had a lot of wildfires this year, but maybe last year there weren't a lot. So give us some talking points about like year over year. I mean, look at the Sierra Nevada in California. They had a 4-year drought. I think it was like 2013 to 17 or somewhere in there. And then they had some huge winters. So what's going on with the year by year abnormality? Mackenzie, why don't you start?
Sure, I'll start. And I think I mentioned this earlier, but I'll just say it again, that climate change equals climate variability. And that what's really important is not to focus on any one season or any one event, but to look at the trend in those events and how those are changing over time. And what we're seeing now with forest fires is that when they do come, they're much more intense, and they burn hotter, they burn for longer, they burn larger areas. So we might be getting more or less in any individual season relative, to the seasons that we remember, and our memories are so anecdotal. But if we look at the trend in forest fires, we know more areas burning, and the areas that are burning more intense.
Yeah, that's really good. So you're saying like maybe standing up on the floor of the Senate holding a snowball wouldn't actually be like a good answer? I'm sorry. I just have to poke some fun there.
Yeah.
This is a question. This is a question from Sean, and he says, "Seems like many of the reservoirs in Colorado are being drained earlier and earlier in the summer, and they're so important for obviously for water storage. It's coming out of the snowpack. Do we have any data on the impact this has on people who count on that steady water flow each year?" Keith, is that something you could touch on, like the importance of storage and I saw on your slide you put up earlier, the mountains are a water tower. They are a reservoir, but then it comes into oftentimes human-built reservoirs. So how is that changing?
Yeah, totally. I don't deal a lot with reservoirs, but the storage is critical. And one of the major uses of our water resources is agriculture. It's something like 80% of the water is used by agriculture in the West. And there are better practices, and our water efficiency in agriculture is improving. It has to. And so California is kind of leading the way with water efficiency in agriculture. And I think that is the future rather than, so we have to be more efficient with our water as our snowpack storage declines and diminishes in many places. And so just having a microscope to that water, watching those water levels in those reservoirs, and then adapting. I think that's the answer.
I like that. And, want to protect our winters sort of main focuses is reducing overall carbon footprint of the human race. And whether that's transportation or buildings or outdoor recreation, whatever it is, the technology is there. We just need the political will to pull this stuff off. So that's a great comment about California and water resource efficiency. And I think that's something that everyone in the drought stricken American West can focus on. And boy, if I was a politician running for office, water efficiency seems like a pretty good platform. Not much of an argument against that one. Mackenzie, I have a question for you. Being a skier, this is from Kyle. How is avalanche danger potentially going to change? Is there going to be more persistent slab type problems? We could break that down in kind of like maybe a bigger picture. I mean, snowier winters are generally good for the snowpack, right? A deeper snowpack is a more stable snowpack. A shallower one, like we have right here in Colorado, tends to be weaker. What are your thoughts on snowpack and avalanches as it relates to climate change?
Yeah, so there's kind of two directions that you can take this, and I'll preface this by saying we don't really actually know, but we can take our understanding of avalanches and our understanding of snow and kind of combine them and say one direction is that snowpack might actually get more stable because it could be warmer and it's falling at warmer temperatures, and we know that warmer snow bonds more quickly and is more cohesive than this cold snow that can form weak layers. But on the other hand, snow is going to get more variable. So we could have more of these, sort of one-off early season events that leads to the formation of depth hoar and weak layers before we actually get our really deep snowpack later on. So that kind of change, it's really hard to say exactly which direction it's going to go, depending, it depends on where you are and your elevation band, like Keith was talking about earlier. And so I think that it could actually get better in some places, and then higher avalanche danger in other places.
Yeah, I mean, I think that's a tough thing to predict, but the fact that it might be better in some places, just don't let the word out because everybody's going to go there. Keith, so Carter had a question. He loved your slides that you presented from the National Center for Atmospheric Research, NCAR. Where can he access that? And we will put it up on the chat for people to click on.
Cool, thanks Carter. That study is actually in review right now. So during the peer review process, we just kind of wait wait until it's published, and then once it is, I'm happy to share that with POW.
That's great.
I could also make it available on social media as well.
Oh, that'd be awesome. Yeah, let's put it up. Let's put it up on social media, and I think it's super interesting. For Keith, again, how much of this change that we're seeing is attributed to what would be falling as snow instead of falling as rain due to temperature change only? Okay, that's interesting. So we're having more melting events in the middle of the winter, shorter season. Yeah, comment on that.
Yeah, it would be hard to disentangle. It would depend, like Mackenzie said, on elevation. If you focused in on some lower elevations around the base of Squaw Mountain, for example, yeah, it's rain. It's a phase change, and it's a shift from. And so I think rain on snow is a big one. It's not only big from a skier perspective, from an avalanche perspective, because we don't fully understand wet slides as well as we probably could. But it's also a big impact on communities because of flood risk. And so phase change is huge and impacting society.
Yeah, absolutely. Mackenzie, people seem pretty fascinated about the dust conversation and the dust slides. That's, I think, super interesting because it's like a visual impact about climate that we can actually see. So Vicky said, one, where is the dust coming from? And then Sean said, how does the dust impact the net radiative balance in the Mountain West?
Yeah, that's great. So the dust is the majority of dust that we see that's melting our snowpack is regional. So we know that it's coming from, basically you can think of it as like the Four Corners region. So, you know, where Colorado and Utah, Mexico, where those meet, those arid regions, the little Colorado River corridor, basically directly downwind of the Rockies. And that blows, our winds are, you know, generally southwest trending, southwest trending. And so when those winds blow across those landscapes, it goes directly up into the Rocky Mountains.
Yeah.
And then the radiative balance question, somebody knows what they're talking about out there. That just means how much additional sunlight is being absorbed by the snowpack. And the easiest way for me to make this digestible by most people is if we think about snow reflectivity as being a number between 0 and 1, where 0 is totally absorptive and 1 is totally reflective. Fresh snow is really close to 1. When we add dust to it, it brings it down to like 0.5 or 0.4. So it's absorbing double the amount of sunlight that it would if the dust wasn't there. So it changes that absorbed sunlight by a lot.
Interesting. One more question. Charlie added, any dust or anything on the snow coming from coal-fired power plants or fires? Is that a thing?
Yeah, so what we call soot is the common term for, in science, what we call black carbon. And black carbon is the most absorptive aerosol that we have in the atmosphere. And it does get on the snow, but in the Western US specifically, it is not as big of an impact as dust. There's just so much more dust than there is black carbon that the black carbon impact is sort of just washed out by the dust impact.
Awesome. Well, I'd love to give you guys a minute or two to kind of wrap up our conversation right here. Thank you guys, our viewers, for joining us tonight. We've taken quite a bit of your time. Keith, you want some final comments on Climate Science 101 in the Rocky Mountains here?
Yeah, you know, and maybe I'll ping Joe's questions. Or Joe asks, looks like Colorado's high country is projected at -10% through 2085. Like I said, 10% reduction in snowpack. But what about the length of future snow seasons? And so that's a great question. The length is actually projected to decline. And so I drilled into this map that I showed briefly, and the reduction is about a month of the snow season, even up at the base of A Basin, for example. So super high elevation, one of the highest elevation ski areas in North America. A reduction of a month. Now that means that if you're going to the beach at A Basin in your Hawaiian shirts in July 4th weekend right now, it means in the future it'll probably be more like early June.
Bummer. One more question for you, Keith. It just came up. We have a lot of people that want to get interested or want to get involved. They're interested in the conversation and in climate. Give us some easy ways for someone to either get involved studying climate science, the impacts in the environment.
Yeah, earth science classes, even at your community college. I mean, I think this is a great time to take some earth science classes at community colleges. There are almost always internships available, and so you could write to either Mackenzie or myself. There are also opportunities at big institutions like NASA, and we can also point you in those directions. But I think education and taking those classes and plugging into things like this. I do the same thing. I listen to podcasts and I listen to experts on different subject matter, and this is when I whet my appetite. You know?
If someone was a student at CU studying environmental science, could they track you down and find you for some of your coursework?
Yes.
All right.
Yep.
All right, Jake, you can find Keith out there. Well, Mackenzie, how about you? Let's finish up some closing thoughts.
I'll just kind of quickly wrap up, and I'll add to what Keith said is that there's other ways to get involved for just like the everyday backcountry skier. Look up community snow observations. You can actually make a probe measurement, make a depth measurement, and upload it as a part of a community science effort. We are interested in how deep the snow is all over the world. So check out community snow observations. And that's just a great way. It doesn't take a bunch of your time, but it's a great way to get involved if you're not at college or taking classes. And then, you know what, I think that climate science and climate change can get a little depressing sometimes, but what I like to encourage people is to not lose hope and to just go outside and enjoy it and pass that on to the people you talk to and interact with, and use that, your love for the outdoors, as part of your story and an influence for talking about climate change. I really think that has more value than just dry science sometimes. So
I would agree with that wholeheartedly. Dr. Mackenzie Skiles, Dr. Keith Musselman, thank you guys so much for joining Protect Our Winners tonight in Future of the Outdoor State, Rocky Mountains. This was an incredible conversation. I want to thank all the participants for your amazing questions. There are some great links in the chat that you guys can click on right now. Open those windows if you want more information. And we love doing this, and we love the fact that you are passionate about the outdoors. So you know what? The election is a little over a month away. Make a plan to vote. Get out there. You're part of the outdoor state, as we all are. So let's do this together. I want to leave you with this short video from our friend Jimmy Chin at Protect Our Winners, and it talks about the importance of showing up in November. So thanks again, Keith and Mackenzie, and see you guys out there. Have a great fall and great winter. Bye-bye.
Bye.
Bye.
If we want to protect the places we love, we must vote. But first, let's start at the beginning. Here, 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 and here. Our country claims to be built on a lot of things: ideals, law, truth. But the one thing that's perfect, what America's actually built on, is the land. This land, this land, this land. This land. For some of us, our ancestors have been here forever. Others arrived centuries ago. Others did not choose to come here at all. And others were simply our parents looking to give us new opportunities. But despite our different paths, we all converged here, on this land, not made for you or for me, but for everyone. You see, the land is our common ground. The mountains, the slopes, the forests, the crags, and the coasts, the places we play and the places we escape to. We cannot continue to allow our seasons to shrink, our rivers to be polluted, our skies to warm, and our forests to burn. So we must rally around the other thing that unites us, our right to vote. Because no matter who you are, if you love the land, you are a member of the outdoor state. 50 million people strong, not defined by borders or party lines, but by passion for places we love. Bigger than any other state and more powerful too, but only if we vote. So let's stand for our common ground, whether our common ground looks like this, or this, or this. If you love the land, it's time to make a plan to vote. Make your plan to vote at makeadamnplan.org.